We left off discussing how to build a one sample t interval or confidence interval using a t critical value, and that again is when we do not know the population standard deviation. And so this t critical value is dependent upon the sample size and then what we call degrees of freedom, n-1. So looking at how we would calculate that, looking at the example we have here, calculate t star 29, the critical value, when your sample size is 30 for this situation here. And so we got to calculate it. And I left those instructions. So let's do, let's first look at stat crunch to do that. And so to do a stat crunch, you're going to use a calculator, t calculator, similar to normal, but it's a different distribution. df is degrees of freedom, which was 29 in that case. And we needed to, let's go back to real quick, we needed to calculate a confidence interval for 80%. That means that there is 10% in each of those, right? That 80% means alpha equals 0.20. And so we have 10% in each of those tails. And so looking at there, then we would put 0.10 here. I want the right side, the right tail. And so a critical value is measuring the value that separates the right tail, 10% of that. And so I get 1.31, which is what we get here. How about what's the t critical for a 95% confidence interval? N equals 12. So that's t star 11, degrees of freedom 11. There's the answer, but let's go ahead and calculate that. Let's use the artist stat to do that. So that'll be a t distribution. And so in the t distribution, remember we're talking at 95% confidence. So that's your alpha equals 0.05. And if we cut that in half of the two tails, right? Alpha divided by 2 is 0.025 or 2.5%. So we're going to go ahead and want the right tail, and we want 2.5% to be in there. And so you can see the answers we get here. Oh, my bad here. Let's do this again. We got to change the degrees of freedom. So that was 11. And so there is our 2.201 right here. That's where you get that. Don't forget the degrees of freedom, like I almost did. And so that's what you would do to have to do to calculate the t one sample t interval, the confidence interval for that. And so to do that here's how we're going to construct it. There's 5 things to keep in mind. First, define what is the parameter we're trying to estimate, right? Which would be the mean of the population. What statistical method? What are requirements met? And so again, all of these tools, all of these statistical tools we use require some us to check that some requirements are met. Otherwise, we cannot use these tools that we're teaching you how to do. And so this is what we're looking at here. And we've talked about this in the previous lesson too, that the samples are independent, where the size is less than 5% of the population size. There's that independence rule we've talked about previously. Simple random samples used in this process of the data collection. And the sample's large enough, right? And the data would be nearly normal, meaning that either in these conditions your sample size is greater than or equal to 30, and if it's not, if the data is approximately normal, then we can go ahead and use these techniques. And then the step 5 is then making a statement about our conclusion, right? We are a certain % confident that the values we found, right, the interval values, actually contain the true population mean. And we'll look at proportions in the future, which we bring up here. And so these are the tools you'll use to do those calculations, using stat crunch here and then the artist stat over here to do that. And so here's the first example we have here. And again, the data is here already, so you can see the work is completed. We're calculating the mean. That's our what we're trying to estimate, the mean population speed of cars on the 5 freeway. We're going to use a 1 sample t interval. In the previous lesson, we used a z interval, but this is a t. And then we meet all the conditions here. You can take a look, and then we calculate it. We need the t star for 11, right? The critical t for 11, which we already know. Why do we use this one here? Because n is 12 and degrees of freedom. And once you have that, you just plug everything in the way we've done, because we have the sample mean and the sample standard deviation, which then we plugged in right here. And so then you can see the calculations we get. And so these values here, this second here was your point estimate. This is your margin of error. 2.592 is what you would get when you multiply that out. And so then we end up saying we are 95% confident that the mean speed of all cars on the 5 freeway is between 58 and 63 miles per hour. And again, that's our estimate, because we don't know what the actual is. I didn't measure every car. That's our estimate that we would come up with. And then looking at the next example here, it's the same thing. Take a look. You can pause and look to see where I got my values from. Again, this t star is an important one in this case because of the sample size in this case is 35, so our degrees of freedom is 34. So you would use your t calculator in StatCrunch, or the t distribution in ArtStat. Again, I've checked all of the conditions. Notice where the values come from. There's your point estimate. That's your sample. This is your sample standard deviation. And so then that's the values we're using here to calculate. And so you check to make sure you get this. In the end, we would see we're 95% confident that the mean amount the cans are filled is between 11.88 and 11.96 ounces. So it looks like it's a little less than 12, our estimate would be.